Welcome to the College Algebra Lesson 17 class activities. Okay, so I'm going to put myself in this first circle here. Caitlin, right? So the mother of Caitlin is Claudia, and Claudia's father is Donald, which means that F of M of P, because that's the order I went. So P was me, then we went M for my mother, and then we went F for my mother's father, Donald. So Donald is my maternal grandfather. And I sort of jumped over the order. We saw in the demo that the order that you compose two functions does matter. But let's say I switched these. Let's say we did F and then M. So if we start with me, Caitlin, my father is Paul, and Paul's mother is Betty. So yes, very different result when you change the order there. Okay, here I have two functions, h and k, and I want to evaluate h of k of 9. So I'm going to start, 9 is the innermost value, that's my x value, and I'm going to plug it into k. Right, you start at the innermost parentheses and work your way out. So I'm going to do k of 9 here. That means the square root of 9, which is 3. So h of k of 9 is really h of 3. Replace k of 9 with the 3. And then h of 3, that's 1 over 3 minus 4, which is 1 over negative 1, which is negative 1. All right, so now I want to determine a general expression for h of k of x. So to follow my format with a number, instead of doing k of 9, I'm going to do k of x as the square root of x. So h of k of x, I can make my replacement, instead of replacing k of 9 with a 3 like I did up here, I'm going to replace k of x with a square root of x because they are equal. Just replace k of x with its formula. So h of the square root of x, that means that if you replace this x with a square root of x, you have to replace every x in the formula with a square root of x. So this is 1 over the square root of x minus 4. What is the domain of h of k of x? I'm going to draw my function machine pictures here. So k is my first machine. So I make my k machine. In goes an x. Out comes square root of x. All right, so k does have some restrictions, right? I can't plug in any negatives into k. So I already know, I'm going to put some notes over here, that as I feed the machine, x has to be bigger than or equal to 0. Can't put a negative in because I'm going to take its square root. Then I have to take the square root of x and feed that into the h machine. And h is 1 over x minus 4, so it's 1 over the square root of x minus 4. So I have to make sure that this denominator is never 0. So I have to make sure that the square root of x is never 4, right? Square root of x can't be 4, or I would break the h machine, right? If I plug in a square root of x into h, if I put the square root of x as 4, if I put a 4 into the h machine, it's going to jam. So the square root of x can't be 4, which means that x can't be 16, right? Because if I feed an x of 16 into the k machine, right, if I put a 16 into k, then out would come a 4. And then if I put a 4 into the h machine, h is 1 over x minus 4, and that would break the h machine. So I have to make sure that I don't put a 4 into h, which means I can't put a 16 into k. So to synthesize my notes here, x has to be bigger than or equal to 0, but not 16. So I would do 0 to 16, union 16 to infinity as my domain. Okay, so I have, here's a visual representation, maybe a slightly better drawing than my function machines, right? We have function machine G, function machine F. You plug your X value into G, you get an output, then you take that output from G and plug it into function F. So I've been given some formulas. The formula for F is x minus 300, for G is 0.85x, and I'm given a value for x, 1400. So I want to use that information to replace x, g of x, and f of g of x with appropriate values. All right, so x is 1400, so I'm going to feed a 1400 into the G machine, and then G is 0.85x, so my output would be 0.85 times 1400, which is 1190. Then I take that 1190 and feed it into the G machine, and G is x minus 300, so 1190 minus 300 is 890. Should be my output. All right, evaluating composite functions using graphs. So f of g of 4. So I don't have a formula now in order to calculate g of 4, but I could use my graph. The blue line is the function g, so just completely ignore the red graph to start. I want to evaluate g of 4. So I find 4 on the x-axis, get the y-coordinate is -2. So instead of f of g of 4, replace g of 4 with its value, which is -2, which I got from the graph. Then I'm going to use the red graph to get the value of f of -2. Find -2 on the x-axis, go up to the red graph, and get the y value of 2. I'm going to erase my lines on the graph here so that I can do another one. G of f of -3. So now I'm starting with an x value of -3, and I need to find the y value on f. So f is the red graph, so I go -3 on x, go up to the red graph, and get the y value is 5. So I'm going to replace f of -3 with a 5, so this becomes g of 5. And then g is the blue graph, so I need to find the y value on g when x is 5. So I find the x value of 5, go down to my graph, get the y value is -3. F of -1. So I'm using only the red graph in this composition. Okay, this is f of -1. So first, I need to evaluate f of -1. Do this innermost part first. So that's asking, what is the y-coordinate on f when x is -1? So I find -1 on x, I go up to the f graph, and I get 1 as my output. So replace f of -1 with a 1. And then I have to evaluate f of 1. So again, I'm using the red graph again, so I find an x value of 1, go up to my graph, and give the y value, which is 5. And f of g of 4, we already did as part A, so that is redundant. We're going to skip it. G of 4. So I'm only using the blue graph now, x value of 4 applied to g. Apply g to an x value of 4. Okay, so g is just the blue graph. So I find an x value of 4, go down to the graph, give the y value is -2. So g of 4, that's g of -2. And then find an x value of -2, give the y value on g. So -2, there's my x value. Go up to g, the y value is 4. All right, lastly, f of g of f of 1. So I'm going to do 3 iterations now. I'm going to start with f of 1. So go up to my graph. I have an x value of 1. I want the y value on f at that x value. So here's my y value of 1, my x value of 1. Go up to the graph of f, the y value is 5. So I can replace just this f of 1 here. It's replaced with a 5. So this is f of g of 5. So now I'm going to work on g of 5. That's an x value of 5. I want the y value on g. Okay, so an x value of 5, the y value on g is -3. So this is f of -3. So now I have an x value of -3. I want the y value on f. -3, f is the red graph, y value is 5. All right, all done with that. Consider the following two functions, f and t. The first function, f, gives a number of gallons of fuel, f of t, a jetliner uses as a function of time in hours, t. The second function, t, gives the time in hours, t of d, as a function of the number of miles flown. So I want to estimate t of 500 and t of 1,000. So t's, right? So I'm going to use the t graph over here, the t graph. So t of 500, find 500 on here. Let's see, that would be 600 there. Halfway between those, that looks like 500. I go up to the graph, read the y value, looks like 1. So t of 500 equals 1. And what that means is that to fly 500 miles takes 1 hour, right? Your output is hours, your input is miles. So to fly 500 miles takes 1 hour. All right, now we'll do t of 1,000. So I look at my graph, I find 1,000 right here. And looks like the y value at when x is 1,000 or when d is 1,000 is 2. So t of 1,000 equals 2. And that says that 1,000-mile flight is 2 hours. All right, now I'm supposed to estimate f of 1 and f of 2. So these are f values I'm looking for. So I'm going to look at my f graph. F of 1, find 1 on the horizontal axis, go up to the graph, give the y value, looks like 250. F of 1 is 250. And to interpret that, the inputs for f is time and the output is gallons of fuel. So a 1-hour flight takes 250 gallons. All right, now I want to evaluate f of 2. So I'll go up to my graph, get an input of 2, and the output looks like about 350. So that says that a 2-hour flight uses 350 gallons. So f of t of 500, we've basically already answered because I know t of 500, I answered up here, is 1. So this is really f of 1, which I already answered in the previous question, which was 250. So what that says is that a 500-mile flight uses 250 gallons. And in an intermediate step in figuring that out was that it takes 1 hour, right? But the answer was is that when you input 500 miles, you get an output of 250 gallons. the 1 is an intermediate there. So that means that f of t of 1,000 is f of 2, which we know is 350. And so what that says is that a 1,000-mile flight uses 350 gallons. The fact that it takes 2 hours is just an intermediate step in answering the question. You are given 1,000 miles and your answer is 350 gallons. 2 was just an intermediate step. All right, so the equation for the first graph is 250 times the square root of t. The equation for the second graph is d over 500. We're going to repeat questions 1 through 3 again, but this time using equations instead of graphs. So t of 500, that means plug 500 into the t formula, which is 500 over 500, which is 1, and that's exactly what we got earlier. And t of 1,000 would be 1,000 over 500, which is 2, which is what we got by looking at the graph also. F of 1 and f of 2. F of 1 would be 250 times the square root of 1, which is 250, which is what we got by looking at the graph. And f of 2, when we looked at the graph, we came up with 350 for this. Let's see what we get if we plug in into the 250 times the square root of t formula. Need a calculator here. Okay, 2 square root of 2 times 250 is 353.55 approximately, which is very close to what we got when we looked at the graph. We estimated 350. So f of t of 500 is 250. And f of t of 1,000 is approximately 353.55. F of t of d symbolically, well, t of d is d over 500. So f of t of d is f of d over 500, which is 250 times the square root of d over 500, which we might be able to simplify, but I'm not going to bother right now.